Toyota has been a trailblazer in engine technology since it introduced the Prius in 1997, contributing significantly to the current electric vehicle (EV) surge. However, despite this early innovation, Toyota has been cautious about fully committing to all-electric vehicles (EVs). Their first fully electric car, the awkwardly named BZ4X, has only seen modest success since its launch, and production isn't set to increase significantly until 2025. Toyota's hesitance was echoed by its president, Akio Toyoda, in a Wall Street Journal report, where he expressed concerns within the auto industry. Despite many considering EVs the future, uncertainty remains about whether they should be the sole focus. Although electric cars are becoming increasingly popular, they still account for only a small percentage of the overall market, leaving space for alternative approaches. Toyota has chosen to explore one such path with the development of the in-engine and innovative internal combustion engine technology that Toyota's leadership believes could rival the prominence of electric vehicles. Toyota, well known for pushing the boundaries of automotive technology, is now making a bold leap with the in-engine. This new technology redefines traditional internal combustion engines, which have remained largely unchanged for over a century. The in-engine boasts a compact, lightweight design and offers significantly more efficiency than conventional engines, all while aligning with environmental goals. Unlike two-stroke engines, it doesn't rely on oil-fuel mixtures for lubrication, thereby minimizing emissions. The breakthrough comes in part due to a crankshaft-free configuration, which employs advanced cam plate and follower mechanisms to convert the linear motion of pistons into efficient circular motion. This design simplifies the engine's construction, reduces its weight, and offers a streamlined, cylindrical form. The in-engine operates on an efficient cycle, completed in just 180 degrees of motor rotation. This efficiency challenges traditional engine classifications, leaving experts debating whether it can be called a two-stroke or one-stroke engine. Toyota's engineers believe even larger versions of the engine could operate with only 60 or even 40 degrees of motor rotation, promising unprecedented torque and performance. Unlike conventional engines with one piston per combustion chamber, the in-engine employs two pistons per chamber, placed on opposite sides. This unique configuration allows for dual piston displacement during a single fuel detonation. Currently, the engine design includes 4 horizontally arranged combustion chambers, each housing 2 pistons, for a total of 8. This innovative setup, inspired by military machinery known for its efficiency and low emissions, allows for a more compact and cost-effective engine, ideal for automotive use. Toyota's development of the in-engine is the result of years of research and experimentation. The company recognized early on that the future of automotive propulsion wouldn't be limited to electric or hybrid vehicles alone, but would also include advances in internal combustion engines. The in-engine represents Toyota's reimagining of the conventional engine, offering an alternative to the electric revolution while maintaining a focus on sustainability and efficiency. With the in-engine, Toyota reaffirms its commitment to exploring diverse paths in automotive technology, pushing the boundaries of performance, efficiency, and environmental sustainability while keeping internal combustion engines relevant in an increasingly electric world. Engineering that defies traditional design paradigms. At the core of Toyota's approach in this development was to ensure that the in-engine could be integrated seamlessly into its existing and future vehicle lineups. This meant designing an engine that was versatile enough to be used in a range of vehicle types without significant modifications. Such versatility demonstrates Toyota's holistic approach towards innovation, where new technologies are developed with an eye on broad applicability and scalability. The Toyota in-engine represents a significant departure from traditional internal combustion engine designs, introducing an array of innovative technical features that set a new standard for efficiency, performance, and compactness. The engine's operation is based on a novel approach that redefines the internal combustion process. Unlike traditional engines that rely on a 4-stroke cycle, intake, compression, power, and exhaust, the in-engine utilizes a simplified 2-stroke cycle that enhances efficiency and power output. This streamlined operation reduces energy loss and increases the engine's responsiveness, providing a driving experience that is both dynamic and efficient. In terms of power output, the Toyota in-engine is designed to deliver exceptional performance without compromising on efficiency. Its power-to-weight ratio is a standout feature, offering impressive horsepower and torque figures while maintaining a lightweight profile. This is particularly beneficial in enhancing the vehicle's overall fuel economy and reducing emissions, aligning with global environmental standards and consumer expectations for greener automotive solutions. When compared to traditional internal combustion engines, the Toyota in-engine represents a paradigm shift. Conventional engines, with their more complex and heavier designs, often suffer from inefficiencies related to their many moving parts and the inherent limitations of the four-stroke cycle. In contrast, the in-engine's simplified, lightweight design and advanced combustion process offer a solution that's more efficient and adaptable to the evolving demands of the automotive industry. Toyota's in-engine is poised to revolutionize the automotive landscape, and its integration into Toyota's vehicle lineup is a testament to the company's commitment to innovation and sustainability. The application of the in-engine across various Toyota models is expected to redefine performance, efficiency, and environmental responsibility in the automotive industry. While specific Toyota models that will feature the in-engine have not been explicitly detailed, its versatile design makes it suitable for many vehicles. This adaptability allows Toyota to implement the in-engine across different segments, enhancing the performance and efficiency of its diverse lineup. For example, the in-engine's small footprint and lightweight design in compact cars can significantly improve fuel efficiency and reduce emissions, a critical factor for city driving and compliance with stringent urban environmental regulations. The in-engine's robust power output and efficient operation can enhance towing capacity and off-road performance without the typical fuel consumption and emissions penalties. This broad applicability ensures that a wide spectrum of consumers can benefit from the advancements the in-engine offers, regardless of their vehicle preference or needs. The engine's design also contributes to a lighter and more compact vehicle architecture, which can offer more interior space and a better overall driving experience. The enhanced performance and reliability of the in-engine also mean that consumers can enjoy a smoother, more responsive ride with fewer maintenance issues over the vehicle's lifespan. For the automotive industry, the introduction of the in-engine by a market leader like Toyota sets a new standard in engine technology, potentially catalyzing a shift toward more sustainable and efficient powertrains across the board. The engine's innovative design could inspire further advancements in internal combustion technology, pushing the envelope of what is possible in terms of performance, efficiency, and environmental stewardship. The enhanced performance and reliability of the in-engine also mean that consumers can enjoy a smoother, more responsive ride with fewer maintenance issues over the vehicle's lifespan. For the automotive industry, the introduction of the in-engine by a market leader like Toyota sets a new standard in engine technology, potentially catalyzing a shift toward more sustainable and efficient powertrains across the board. The engine's innovative design could inspire further advancements in internal combustion technology, pushing the envelope of what is possible in terms of performance, efficiency, and environmental stewardship.